Black holes are not just objects of destruction. They are the universe's most powerful laboratories, places where the extremes of physics are forced into contact with each other, where our greatest theories are tested and, so far, found wanting. Everything we don't yet understand about gravity, about quantum mechanics, about the true nature of space and time. The answers may be locked inside an event horizon, hidden in a singularity, encoded in the slow hiss of Hawking radiation. The universe has been running this experiment for billions of years. We are only just beginning to ask the right questions. If you want to keep exploring the edges of what we know and what we don't, subscribe to Cosmos Unveiled. Every week, we take you further into the universe's deepest mysteries. Next time, the most terrifying places in the known universe, and why several of them are far closer to Earth than you'd be comfortable with. The universe is stranger than you think. Let's find out how strange, together. What we believe is that the singularity represents a place where our current understanding of physics is simply incomplete. We are missing a theory of quantum gravity that reconciles the physics of the very large, which Einstein described, with the physics of the very small, which quantum mechanics describes. At the singularity, both matter simultaneously. And without that theory, the singularity remains the great unanswered question at the heart of the universe's most extreme objects. What actually happens there? We genuinely do not know. Before we close, there is one final problem we need to leave you with. Because physicists are not just puzzled about what happens at the singularity. They are puzzled about something even more fundamental. What happens to information? In quantum mechanics, the rulebook for all subatomic physics, information cannot be destroyed. The details of any physical system, no matter how it changes, can theoretically always be reconstructed. It's one of the bedrock laws of physics. But Hawking radiation, the theoretical process by which black holes slowly evaporate over incomprehensibly long timescales, appears to destroy information entirely. Everything that fell in, every atom, every photon, every piece of data about what you were, appears to simply be gone. This is the black hole information paradox, and it represents one of the deepest unresolved conflicts in theoretical physics. Stephen Hawking spent decades wrestling with it. Some physicists believe the information is somehow encoded in the Hawking radiation that leaks out. Others believe the paradox reveals that one of our most trusted theories is fundamentally wrong. And some believe that at the moment you cross the event horizon, instead of nothing, you encounter a firewall, a wall of high-energy radiation that incinerates you instantly, leaving nothing to reach the singularity at all. Nobody knows which answer is right, which means the universe's most extreme object is still keeping its deepest secrets. You are inside, and there is no going back. Inside a black hole, one of the most fundamental rules of the universe has been rewritten. Outside, you can move freely through space in any direction, while time moves in only one direction, forward. Inside the event horizon, those roles reverse. Moving through time toward the singularity becomes as inevitable and inescapable as moving through space toward the future is outside. You cannot stop your progress toward it any more than you can stop time. It is the geometry of space-time itself pointing you toward the center, and the gravity differential, the difference between the gravitational pull on your head versus your feet, begins to make its gravitational field, the slower time flows within it. Right now, someone watching you from a safe distance back on Earth would notice that your movements are becoming slower. Your watch is ticking at a different rate than theirs. The closer you get, the more dramatic this effect becomes. You don't notice it yourself. From your perspective, everything feels perfectly normal. That is what makes what happens next so deeply strange. You are approaching the event horizon. This is the most misunderstood boundary in all of science. Most people picture it as some kind of visible wall, a crackling energy field, a surface you can see. But the event horizon is invisible. It has no physical substance. It is simply a threshold. The mathematical point at which the escape velocity, the speed you would need to reach in order to escape, becomes greater than the speed of light. And since nothing can travel faster than light, nothing that crosses this line ever leaves. Here is the part that should keep you awake tonight. To an outside observer, to anyone watching you from a safe distance, you never actually cross it. As you approach the event horizon, you appear to slow down more and more dramatically due to time dilation. From their perspective, your image reddens, dims, and you asymptotically approach the event horizon forever, frozen in time, like an insect trapped in amber, never quite making it across. Black holes are not just objects of destruction. They are the universe's most powerful laboratories, places where the extremes of physics are forced into contact with each other, where our greatest theories are tested, and so far found wanting. Everything we don't yet understand about gravity, about quantum mechanics, about the true nature of space and time. The answers may be locked inside an event horizon, hidden in a singularity, encoded in the slow hiss of Hawking radiation. The universe has been running this experiment for billions of years. We are only just beginning to ask the right questions. If you want to keep exploring the edges of what we know and what we don't, subscribe to Cosmos Unveiled. Every week, we take you further into the universe's deepest mysteries. Next time, the most terrifying places in the known universe, and why several of them are far closer to Earth than you'd be comfortable with. The universe is stranger than you think. Let's find out how strange together.